Ladies and gentlemen, I would like to welcome you to our today's discussion where we shall discuss why a power 0 equals to 1 for any value of a being a non-zero. It's common knowledge that the law holds that a power 0 equals to 1 for a not being equal to 0. But it is also important to understand why this is so. Now let us consider the expression a power n divided by a power n. This can also be expressed as a power n divided by a power n. This can be simplified in the ordinary way that we divide fractions to simplify them by cancellation. So we cancel the numerator to give us 1, and we also cancel the denominator to give us 1. Therefore, the expression simplifies to 1, meaning that a power n divided by a power n is equal to 1. For example, a raised to power 4 divided by a raised to 4 gives us a power 4 all over a power 4. Since the numerator and the denominator are the same, we can cancel the numerator to give us 1 and the denominator to give us 1, and therefore the expression simplifies to 1. Now, considering the second law of indices that states that to divide numbers with the same base, we keep the base and subtract the exponents. This law can be written as a power m divided by a power n is equal to a power m minus n. Therefore, applying this law in our earlier expression, a power n divided by a power n, this can be expressed as a power n divided by a power n equals to a common base raised to n minus n. N minus n is 0, and therefore this becomes a power 0. But we had seen earlier that a power n divided by a power n is equal to 1. So a power 0 equals to 1, but we have to give a condition that must be fulfilled for this to be true. And this condition is that a must not be 0. This law is commonly known as the zero index, which states that any non-zero raised to power 0 is 1.